Okay, in this particular video demonstration, we will be discussing text classification using Scikit-learn in natural language processing. So, what is text classification? So, it is basically an essential task in natural language processing that involves assigning text data to predefined categories. It serves as the foundation for applications such as topic categorization, sentiment analysis, spam detection, and labeling systems to automatically understand and organize large volumes of textual information. So coming to the our topic, that is the text classification. So it is a foundational task in natural language processing. It involves assigning predefined categories or labels to class documents. This automated process helps efficiently sort, organize, and manage large volumes of textual data, enables the instruction of meaningful information and insights from unstructured data. Text classification is widely used in applications such as sentinel analysis, spam detection, topic labeling, and document categorization. Um, so in this particular case, we will be using it for the document categorization. So anyhow, we will be using Scikit-learn for this purpose. So Scikit-learn is a widely used open source machine learning library for Python. It provides simple and efficient tools for data mining, data analysis, and machine learning tasks. So it is basically built on top of core science Python libraries such as NumPy, SciPy, and Matplotlib. It offers a rich collection of machine learning algorithms such as classification, regression, clustering, and dimensional reduction, but we will be using it for the classification purpose only. However, uh, there are some more informations about cycle, and you can also search these information on your own. So our main aim in this lecture or demonstration is to classify text into a specific class or category. So if you want to implement text classification with scikit-learn, so there are basically 5 steps to do it. First of all, we'll be importing necessary libraries, and also we will load the data set. Then we will pre-process the data so that it could be able to send for the training on a specific model. Then we'll be training the model for classification. Once the model has been trained, then we will evaluate on the our model on some specific matrix, that how well it has been trained, and we will also define a function to print the class for a new text. So coming to the first step, that is to import necessary libraries and load data set. So for that purpose, we will first, you have to install the scikit-learn library, which is very easy. You can do it on your own. Once you have done that, then what we will do is that from we will import the fetch 20 news group data set. Then we will also pandas at pd. Then we will create a data set with the name news group, and we will be using the name of the data set fetch underscore news group 20 news group. Subset is equal to all, and categories, so we will be basically using the two categories, that is the sports.bateball and sky.space. We also want to shuffle the training data or the data which we'll be using. So that is why we have set is equal to true, and we have set the random seed state is equal to 42, so that the next time we use the code, so we get exact the same shuffle that which we have done this time. So now, in order to separate the data from the labels, we have stored it in the news.groups.data. It fetches the all the data and store it in data, and newsgroup.target actually retrieves the corresponding labels for the data and stores it into the data as well. And then we created pandas data frame, and we have provided text as the input, sorry, data as the input, and label as the target underscore. we have provided text as input, or you can say as a label, and data as its value, and then we have used another key with the name label, and then we have provided target as its value. You can see that these are enclosed in a curly brace, so it means that this is basically a dictionary. So what will happen is that in pandas data frame, text will be one column label, and this label will be the another column label, and all the data will be stored under the text column, and all the targets, that is the class names, will be stored underscore the label. Then we will be printing the data frame so that we could verify that it is working. Okay, so as you can see that we have already um, completed over or executed over this particular code. So as you can see that this is basically the data, and the label is 0. So 0 is assigned to the baseball, and 1 is assigned to the sky space. So as you can see that there are total number of 91980 data with the corresponding labels as well. So now this is the information regarding the fetch 20 news group data set. So by selecting all, it means that we want to fetch both training and test data sets. Categories sports, baseball, and sky space limits the data set to only 2 categories. So there may be some more categories as well. Randomly shuffles the document to avoid ordering biases, ensures the shuffling is reproducible if we execute the course the next time. So if you want to fetch the category names rather than the target names, then you can use the target underscore names as well. So our first step has been completed here, that we have fetched the data. Now the second step is to process the data. So for this purpose, we will be using term frequency inverse document frequency. It has known as the TF-IDF in a short form, and it will be used to translate text into numerical vectors. So what happens is that it is a basically technique to convert the text into numerical vectors. Term frequency, it measures how often a word appears in a document. So if there is a word appears 10 times in a single document, then its frequency will be 10, and if it appears 100 times, its frequency will be 100 as well. And then there is a terminology inverse document frequency. So it reduces the weight of words that appears in many documents, highlighting the words that are more unique and meaningful. So it reduces the weight of such words that has appeared very frequently among all the documents. So we will also be controlling or we will also setting as thresholds for such words as well in later on, or just in a while. Combines TF-IDF to assign higher importance to words that are frequent in documents but rare across the dataset. So, in order to use TF-IDF, we have to import this TF-IDF vectorizer, and then we have created an object with the name vectorizer, and we are using the name of the class TF-IDF vectorizer, and then we have used the stop words is equal to English. So it means that all the English like words, example the, is, and, of, will be automatically removed from the data set and will not be taking part into the TF and IDF. And we have also set max DF is equal to 0.71. So by setting max DF is equal to 0.71 means that it ignores words that appear more than 70% of document. With such higher frequency, words usually carry little information. So that is why we also have ignored such words that have appeared abundantly, that is 70% of the document. Okay, so these are the only two parameters which we have used here. So it will create an object, and then what we are doing is that we are providing the data to the vectorizer, so it will convert all the data into the numerical vectors uh, that will be truly based on the TF-IDF. So it will ignore the English stop words, and it will also remove the words that have appeared abundantly in 70% of the documents. So now what we are doing is that we are also storing the labels in the variable y as well. Okay, so we have gone through all of the above, so just let's execute the code. So the code has been executed, and just in order to make sure that the x, which is basically the the one that contains only the data and it does not have any information regarding the labels, and then we will be displaying what x actually, what are its dimension and look likes, and then we will also print x as well. So we first display the type of the x. So basically it is a matrix of the Scikit-learn, and then it contains numeric values, that is floating point values, and then it has about 20,000 and 9812 stored elements in compressed sparse row format. So this is basically overall values stored in the rows and columns. So as you can see that there are about 1980 rows, and there are about a lot of columns as well. So in a nutshell, the overall number of elements stored in that matrix is 20,912. Anyhow, now you can see that the element stored at 1980 row and column number 14873 is this particular value. Explanation of the sparse matrix. So sparse matrix CSR format is efficient if it is too large. Multi-zero matrices saving memory in computation formats. Alright, the matrix has 1981 rows, each one fully documented in the data set. And the matrix has 271120 column, each for unique words or feature in the TF-IDF vectorizer. So there are about, you can say, 27,120 words that has been identified in 1981 documents. So it has 64-bit floating point values, stored elements, okay, and there is a lot of other information. Efficient, why you have used CSR comma separated, why you have used this CSR. So it's efficient storage and computation of large space matrices. Only non-zero values are stored and reducing memory storage, so on and so forth. So now the third step is to, so we have now pre-processed the data. As you can see that the data has been converted into this vectorization form in a matrix kind of structure, and now we would like to train our model based on this particular matrix values. So for classification purposes, we will be using support vector machines. So what is support vector machine? A supervised machine. A supervised machine. A supervised machine learning algorithm used for classification and regression tasks. And text classification is primarily used for binary multi-class classification. So in our particular case, we will be using binary classification because we only have two classes, that is the baseball sport and the sky science, or you guess sky space science space, I guess. Okay, the core idea is to find the hyperplane that best separates data points of different classes in a high dimensional feature space. It maximizes the margin between classes, distance between the closest point of each class to the hyperplane. It also helps improve generalization on unseen data. Kernel trick transforms data into high dimensional space. I think we have not yet seen the code, if I'm not wrong. Okay, the code is yet to be shown here. So let's first get to the code. So we are using a train split uh, class here, and we also importing the support vector machine class as well. So what we are doing here is that we are using the train test split. So this is basically a class, and it requires four parameters, and as a result it also returns four values as well. The first value is the xtrain data. It means the data to be used for training purposes, and then also data that will be used for the testing purposes. The label that will be used for the training purposes, and the label that will be used for the testing purposes. And it also requires this train test split. I suppose it's a class. If it's not class, then it definitely will be a method, because sorry, function, because the name of this particular function starts with a small letter. So as a good programming practice, we can reckon that it is a function rather than the class. So this class requires four parameters. The very first one is the uh, data, and the second one is the label of that particular data. Third one is the splitting the data into the train and split. So it means that we are using 30% of data for the testing, and 70% of data for the training. Random state is equal to 42, so that the data that has been used for the training, that has been split for training and testing, will be exactly the same, so that when we want to reproduce this code, or whoever else want to reproduce this code, as a result, what we are doing is that we are calling a constructor of the support vector machine. We are setting the color is equal to linear. uh, there is just information about the linear. A type of kernel function use linear, poly, RBF, etc. So there are a lot of kernel varieties available here. So there are also other regularization parameters that control the trade-off between maximizing the margin and minimizing the classification error. So you can use this as a regularization parameter, and gamma defines the influence of a training, example RBF kernel. So you can use these other options as well. Anyhow, once we have set the settings for the SVC, then there is a finally the time to train these particular model. So fit function is using for training the model. So we have provided two data here, the training data to the kernel, also provided the training labels to this particular model as well. The model will now be trained after executing this particular work. So it took a very small time in training, because the size of data set is not very much big, so that is why it took very much small time. So we already discussed all these things that was used for the train test split function, and then we also discussed what these things are, so there is no need to discuss these things in detail anymore. The final step is to model, not the final, but the second last step is to evaluate the model, that how well our model has been trained. So in order to do that, we are importing two metrics. First one, the accuracy score. The second one is classification report. So in order to uh, predict the model, what we are doing is that we are calling the prediction method, and we are providing the test data to it. After providing the test data, it will predict the labels for it and store the labels as a list, or you can say as a vector or one dimensionally in the Y prediction. And then it's time to evaluate the performance of the model. So in order to evaluate the accuracy, we are using the accuracy score function, and we are providing it the testing data, testing labels and the um, prediction labels. So after comparing the testing labels with the prediction label, it will evaluate its accuracy score. So now in order to do some additional metrics such as precision, recall, F1 score and support, what we are doing is we are using the function classification report. So we are providing it the test labels and the predict labels. Target names is equal to news group dot target names as well, so that it could match all these things at once as well. At the end, we are printing the classification accuracy and classification report as well. So as a result, you can see that it has produced 0.996699.6% accuracy, and we also have very good precision of 99%, recall of 100%, F1 score of 100%, and support of 286 for the baseball, and support of 309 for the sky space. We also have the 100% precision for the sky space as well. We have a 0.99 recall for the sky space, which is more or less the same for the base boy and sky as well. Anyhow, uh, we also know the explanation of all the code we have discussed about so far. So it's finally time to define a function to create the class for the new input of text or new input of data. So what we are doing is that we are creating a new function. This function will take the string as input, and once you input the string, first we will transform this string into the um, numerical vector matrix using the vectorizer, TDEF IDF, you can say, or vectorizer that just transforms it into the matrix form. Once its form has been changed, we will be using this uh, pre-processed data and provide it as input to the model so that it could predict its label. And what we will do is that we will return its labeled target name rather than the class in zeros and one. So we have set the sample text is moon is very shiny tonight, and then it will vectorize it, and we'll provide the pre-processed data that is in the numerical form now as a matrix form to the function. The function will predict it. Uh, sorry, the function will actually first transform it from the text into numerical data and provide it to the model. The model will predict its label, and the label will be provided as a label name instead of the 0 and 1, and that string will be stored in the predict category. As a result, what we will do is that we will print it in the output. So let's execute it. So as you can see that moon is very shiny tonight, it has predicted its label as sky space, which is correct. So if I say something like the player is very tall now, because it has detected some words that may be tall and player may be based on this particular TF-ID of value, it has reckoned that this belongs to the baseball. So let's use something else. The weather is good for today's play. Let's see, again it's again related to the baseball. So one more thing, so sky space is that stars are bright tonight. So this might be a little bit confusing to the model. The reason is that because we do have stars in the baseball players, the one who have gained very much high popularity, they become stars. So that's why um, this might be a little bit confusing. So we need to change that stars are far away from Earth. So now again, because this particular statement contains such words that are abundantly used in the sky space data set. So this is it from today. And if there are any questions, you can ask in the comments. Thank you very much for watching.